So now I'm going to walk you through these two examples here, so this one and this one. So first we're looking at the integral from 0 to 2 pi of the function sine of x dx. Okay, so I've written some explanation here, but I'll say it out loud now. Okay, so we can see here in the dashed green line, this is the graph of sine of x. And right now we're computing these integrals, so we're finding the number that these integrals are by interpreting it in terms of area, right? So what is the area that this integral is describing? We figure that out, and then that's what the value of the integral is. Okay, so in this case, we're looking at the integral of the function sine of x, so that's in green, and then between 0 and 2 pi, right? So 0 is right here, and then 2 pi is over here, right? So you might be able to see this is 6, so this is like a little bit over 6, right? So that's around 2 pi. Okay, so the way that we're going to compute this and think about this is actually that we know something about sine, right? Sine is periodic. It has the same values, it repeats the same values over and over again. So if you think about the values of sine between 0 and pi, so that's in this little area, they're actually the same as the values of sine between pi and pi over 2, except we have to multiply them by a negative, right? So the numbers up here are all the same as the numbers down here, except these down here have been multiplied by a negative, right? So for example, here I've got the value 1, right? The y value is 1, and down here it's the same, except now it's negative, right? So it's been multiplied by a negative. And the same can be said about all of the values on here and all of the values on here. So that tells me that the area beneath here is actually the same, so there's the same amount of surface area here as there is here. And because we know something about integrals, we know that this area will be counted as positive area, and this area will be counted as negative area, right? And then they'll be added together. So if I take this area, add this negative area, because they're the same area, they're going to cancel out, right? So because of the symmetry of the graph of sine, this area and this area together cancel out because this is counted as negative area. And so we get that the integral is actually 0. Okay? So maybe you should take some time and try to think about how can you do this? How can you set up an integral with maybe the graph of cosine that will also give you 0? Okay? Now let's talk about this second example. So this one is this now. So again, we're trying to find the value of the integral. And we're going to do it by thinking of this integral in terms of area, right? What is this describing in terms of area? So again, I've written a bit of explanation here, but I'll talk about it a bit more. So here, we're looking at the equation that's on the inside here. I'm going to take this equation and I'm going to manipulate it a bit, right? I'm going to do something to it here. So let's see, maybe we'll use black. Okay. So if we take the equation y equals square root of 4 minus x squared, we're going to manipulate it a little, right? So maybe let's square both sides. So we get y squared equals 4 minus x squared. And now let's add that minus x squared over to the other side, right? So we're going to get x squared plus y squared equals 4. So now you might recognize this type of equation. Maybe it's something you've seen before, but this is the equation of a circle. Okay, so this is the equation of a circle with center at 0, 0, and radius. So radius r equals 2. So usually in the equation of a circle, this is the radius squared, right? So if I take the square root of this number, then I get the radius, right? So this is usually the radius squared, okay? So because this is the equation of a circle, right? This is the equation of a circle, really. We know that we're looking at the equation of a circle here. Now notice this is the positive square root, positive. So that means we're really only looking at the upper half of the circle, right? If there was a negative on there, then we'd be looking at the lower half of the circle. Okay, so because this is positive, we know we're looking at the upper half of a circle. And look, radius 2, so from 0 to 2, that's the radius. So now, so that tells us we're looking at this half of the circle, right? Now, if we look at the bounds for our integral, right? So here this is saying integrate from 0 to 2. That tells us actually we're only looking at this part of the circle, this quarter of the circle. Okay, so when we compute our integral, we're really only looking for the area in here, right? So this is 1/4 of a circle. So if you think about that, we just need to come up with what is the area of the complete circle with radius 2, right? From here to here, that's 2. And then cut it into a fourth, right? So we'll find the full area and then only take 1/4 of it. Okay? So if you think about the area of a circle, so here we go. So the area of a circle is pi r squared, right? This is just a formula we know. This is the same as pi, so r is equal to 2 in this case, right? So I'm going to go ahead and square that, so that'll be 4. So it'll be 4 pi. So this is the area of a complete circle, right? So area, so maybe we'll do this. So area of a full circle. So now to get the area that we need, right? So the quarter circle, we're going to take this area, right? So this is 4 pi and divide it by 4, right? Because we only need 1/4 of it. So take this, divide it by 4, that's going to get rid of this 4. So I'll only be left with pi, right? So the area here should just be pi, right? And you can see that's what we end up getting, right? So this integral is equal to